Hello and welcome to my science tutorials. This is the second part of the binomial expansion. The first part we look at how to use Pascal's triangle, and in this example we are going to look at the binomial expansion or the theorem itself, and then how we use that to solve problems. So let's get started. So the general form of any binomial is given by a plus x raised to the power n. Okay, so the expansion for this using the binomial and not the Pascal's triangle is what? First, we have the a value we have over here. Let me use another color. So the a value we have over here, we have the a raised to the power n as the first term, then plus what we have as the second term will be what? We have the n becoming, like, it will now come to the, like, it will not be first, and then we have the a. Then we decrease the power of the n, so it will be n minus 1. Then we introduce the x, then plus, then we decrease the n over here, so it will be n minus 1, then a n minus 2. The power of the a will now decrease by 2 instead of 1. Then we have the x now being squared. Then we divide this by 2 factorial, then plus n minus 1, n minus 2. This will now have n minus 2. Then we have a n minus 3 s cubed all over what? 3 factorial. Plus, you'll be doing this n minus 1, n minus 2, n minus 3, then a n minus 4 s4 divided by 4 factorial till you have what? X raised to the power n. So this is the general way of expanding a binomial using the theorem. Now remember, I made mention of some new terms over here, this and this. I said 3 factorial, 2 factorial. So what the hell is factorial at all? So factorial is very simple. So 2 factorial means what? 2 times 1. So 3 factorial implies what? 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Hey, this one is too long. 5 factorial is what? 5 times 4 times 3 times 2 times 1. Exactly. So this is what we mean by factorial, and then this is the general way of expanding a binomial using the binomial theorem. So let's have a look at an example to see how we can apply this way of expansion to solve a particular problem. Okay, so now before we look at that, we have something that I really need to tell you guys. I think it will become useful some part in your objectives. So assuming you are asked to find, like, without expanding at all, you are just asked to find the coefficient of the s cubed term, okay, in case you are to expand, but you are not supposed to expand. How will you do this? So there's a general term used to find that. So we have n combination r, then we have a n minus r x r. Wait, before you start shouting what am I doing, please let me expand this for you so that you know what I mean, and then I will explain and you have a practical example how to use this. So this simply means we have n minus 1, n minus 2, okay, so we have what? N minus r plus 1, okay, all divided by r factorial, okay, then a n minus r x power r, okay. So I know this still sounds confusing, so let's have a look at a practical example so that we can appreciate what I mean by this. Okay, so let's have an example. They say find the coefficient of the s cubed term of the binomial expression. So we have 1 plus 3x raised to the power 12, okay, and we have to find the coefficient of the what? The s cubed term, okay. Now can you see that we have power 12 over here? So I'm telling you, if you are to expand this way to the power of 12 just because you want to get the coefficient of the s cubed term, it will be very long, I tell you. So you need to simplify this. So now to write this, let's take good note of this. So how do we now solve this problem? Well, this whole thing can be written as the n over here. Let's jot some terms down. Okay, the n is the power, which is the 12 over here. Okay, so the x, okay, if we have a plus x raised to the power n, okay, comparing this to this, okay, so the n is the 12 over here, and then the a will be the 1 over here, is 1, and then our x will be what? 3x. The x over here will correspond to the 3x over here, okay, and then our r is equal to the 3 that they are talking about over here, so it's the 3. Okay, so using this, and let's put all of this into this, and then we'll get, so we have here we have 12 combination what? R, which is 3. Then the a we have is where is our a? Oh, this is supposed to be a, sorry about that. So this is a, so our a is 1, so we have 1. Then the n is 12. Okay, so 12 minus the r, which is 3, will give us 9. Okay, then we have our x here is 3x, so we have 3x, then raised to the power r, the r is 3. Okay, so this is what we will get. Okay, now I'm taking my time to explain everything so that you can understand to my maximum best. I'm explaining to my maximum best. Okay, so let's shrink this down, and then let's send it to the top. Okay, so if we have this, how are we going to do the expansion? This is very simple, because we are looking for they said the s cube term. Okay, it means we need to have 3 terms in front of the s cube. Okay, and that 3 terms we will get it from what? The n minus 1, n minus 2. Okay, so 3, we have 3 over here. Okay, then our a, which is this one over here, we'll still repeat that, 1 power 9. Then we have our 3x power 3 over here, this is 3. Okay, so it means the 12 combination 3 is what? n minus 1, n minus 2, all divided by 3 factorial. Remember, we are dealing with 3 over here, so we divide by 3 factorial. So we have this. So all we need to do is to input the value of n, and then we solve this. So the value of n is 12. Now 12 minus 1 is 11, 12 minus 2 is 10, all divided by what? 3 factorial, which is 3 times 2 times 1, 1 power 9, then 3x raised to the power cube. So we expand this all, we will get what? 5940 s cube. Okay, so with this, straight away we can say what? The coefficient of the s cube term that we've been asked is what? 5940. So so just get more example and then try it out, and I'm sure you'll be okay with this. It's really helpful in terms of objectives in an exam or in a class test. Now let's have a practical example how we are going to do the expansion during using binomial theorem. So example number 1. So let's expand 2 plus x raised to the power 7 using the binomial expansion. So first of all, we write the general term. Okay, so we write a plus x raised to the power n, and then what is the expansion? So we have n, okay, a power n, then plus n, a power n minus 1 x, plus n minus 1, a n minus 2. The x will not be squared, we divide by what? 2 factorial, plus then this will increase, n minus 1, n minus 2, a n minus 3, s cube all over 3 factorial, plus, and it continues that way till end up with a power of 7. Okay, alright, so having this general expansion, we can go straight away and expand and get our answer. So we have 2 plus x raised to the power 7. So what we will be having, we will be having the first term, which is the a. So we have 2 power 7 first, then plus, then we will be having 7, which is the n over here, then the 2, the a is the 2 over here, so we have 2 power 6, then we have x, then plus 7, then we have 6, there is the n is the 7, n minus 1 is the 6, then we have the a, which is 2, n minus 2, 7 minus 2 is 5, s squared, okay, then divided by 2 factorial, okay, then plus 2 factorial, so plus 7, 6, 5, okay, then we have the 2 raised to the power 4, the x power will increase by 3, we divide by 3 factorial, then plus, we go on, so we have 7.6.5.4, the dot are to represent multiplication. Let me just write it down to avoid confusion. Then times 2 raised to the power 3, okay, divided by 4 factorial, and then we have our x power 4 times over here, then plus 7, 6, 5, 4, 3, okay, here we don't have the 3, so here we have to have the 3, then the 2 will come, then the power will decrease over here, we have 2, the x power will increase 5, divided by what, 5 factorial, then plus 7, 6, 5, 4, 3, 2, then well, let me do this on another place so that we can see. So yes, so that expansion will be what, 7, 6, 5, 4, 3, 2, this is 3, 2, and then we have the 2 here is the power 1, then we have the x, the power will increase to 6, all divided by 6 factorial, then plus the last expansion for this, we have 7, 6, 5, 4, 3, 2, 1, then the 2 will now have power of 0, which is still 1, so 2 power 0, x power 7, all over what, 7 factorial. Now this is beautiful. Let me get some space at the top over here so that we can continue. Okay, so all of this now will be equal to, now 2 raised to the power 7 will give us 128, then plus, if you expand 7 times 2 raised to the power 6 will give us 448x, plus the whole of this 7 times 6 times 2 raised to the power 5 divided by 2 factorial, which is 2 times 1, will give us what, 672s squared, plus 7 times 6 times 5 times 2 to the power 4 divided by 3 factorial, which is 3 times 2 times 1, will give us what, 560 x cubed. So the same way, all of this will be giving us a certain value. Let me quickly write them down. X power 4 plus x 84, x power 5 plus 14, x power 6. Now the last one, which is this. Now let's take a look at something. This is interesting. So we have here 7 times 6 times 5 times 4 times 3 times 2 times 1. Does that sound a bell? Yes. That is exactly equivalent to 7 factorial, because I explained 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. So the 7 factorial over here cancels the whole of this. And now 2 raised to the power 0 is 1. So 1 times x raised to the power 7 is still x raised to the power 7. So we have here x power 7. So that is how we solve an example using the binomial way of expansion. So I hope we are all here, so I can get rid of all of this, and then we solve the second example and we say goodbye. So example number 2. Now the example number 2, we are to expand 3 minus 2x raised to the power 5. So without writing the general way of expansion first, which is we need to write them down first, just so that you know, like, so let me just write it down. So a plus x raised to the power n will give us what? A raised to the power n plus n, a n minus 1 x. I'm sure by now you are getting used to the trend. N minus 1, then we have a n minus 2 s square, all divided by 2 factorial, plus n minus 1 n minus 2 a n minus 3 s cube all over 3 factorial, and it continues. So we write our question, which is 3 minus 2x power 5. So we expand. So we have 3 raised to the power 5 plus 5 into bracket 3 power 4. Then our x term in this example is what? Negative 2x. So we write the negative 2x over here. Then plus 5, 4, 3 will have cube. Then negative 2x square. This is 3. Guys, be getting used to my 3. Then plus 5, 4, 3. Then the 3 will have squared. Then we have our negative 2x will now have the power of 3 divided by 3 factorial. Then plus we have 5, 4, 3, 2, then 3 raised to the power 1, negative 2x raised to the power 4, all over 4 factorial. Then plus the last expansion for this will be 5 times 4 times 3 times 2 times 1, and then divided by 5 factorial. Then we will have our 3 will be raised to the power 0. Then we will have our negative 2x raised to the power 5. So let me get rid of this, and let me bring this up. Okay, so from here 3 raised to the power 5 will give us 243. Then plus, now 5 times 3 raised to the power 4 times negative 2 will give us what? Negative 810x, plus then the whole of this divided by 2 factorial will give us 1080 s square. Then the next one will give us negative 720 s cube. Then we will have 240 x power 4, then minus this, the last example again. 5 factorial is what? 5 times 4 times 3 times 2 times 1. So you don't need to input this into the calculator before you get. Just cancel this with this. 3 power 0 is 1. So this is also 1 times. So you just have to have like the last term, which is negative 2 raised to the power 5 will give us what? Negative 32. So 32. Then the x will have the power of 5. So yes, this is how we use the binomial expansion or the binomial theorem to solve a problem. So thanks you guys for watching. I hope you learned something, and then I will see you in the next video. So if you are new to this channel, kindly subscribe. I will post tutorial videos every single day, so be sure to subscribe and then turn on the notification button to get informed whenever we upload a video. Thanks for watching, and we'll see you in the next video.